Hey guys, so this is lesson 710, cones, ratio of volumes, and modeling questions. Okay, so this first question was a 6-point question on the very first exam ever released. That water tower question was also on the same exam. So at the time, they actually had 2 6-point questions. So they changed that now so that our exam only has 1 6-point question because kids weren't finishing their exams in time, which is kind of funny, but... Okay, so like this first question says, a water glass can be modeled by a truncated right cone, a cone that is cut parallel to its base. So they call this a truncated cone. So the diameter of the top of the glass is 3 inches. The diameter of the bottom of the glass is 2 inches, and the height of the glass is 5 inches. So I'm just going to label that info real quick. So they're telling you this diameter right here is a 3. The diameter of this one is a 2. And then they're telling you that the height of just the glass, so we're talking about just this glass part, is a 5. Okay. The base with a diameter of 2 inches must be parallel to the base of the diameter of 3 inches in order to find the height of the cone. Why? So in other words, they're saying if you wanted to find the height of this cone, why do those two bases have to be parallel to each other? Okay. So you want to kind of think about this two-dimensionally. Like that's why they're giving you guys a picture of a two-dimensional cross-section perpendicular to the bases. So think about like this picture kind of broken down simplistically. So if I had looked at it like this, where this is 3, this is 2, this is like say X roughly, top to bottom. You're looking at this as 2 overlapping similar triangles. So we're going to be able to figure out what the height of the cone is, or this whole cone, by pretty much doing proportions of sides. But in order for this to work, we need these to be parallel, because if these are parallel, then we end up having corresponding angles congruent, and then they are similar. Okay, so that's kind of going to be what we write down here for this first part. We're going to say the diameters must be parallel. So that corresponding angles are congruent. Resulting in similar triangles. Corresponding sides of similar triangles are in proportion. So a proportion could be used to find the height. Okay, so now let's actually try finding the height. So now I know they're not actually giving you guys the sides. They're actually giving you this length right here, like this is 5, and then they're asking for the whole height of the whole thing. It doesn't matter whether we write them along the side or like this. It's giving us some sort of proportion of side lengths within the triangles. So we know they're all in the same proportion. The proportion is going to be a 2 to 3 proportion. So if you guys look at this picture, I'm going to have 2 over 3 is going to be equal to, now the side for that's going to correspond to 2 would be this whole height, x minus the 5. So this length right here is represented as x minus 5. So when I go to write my proportion out, I'm going to do x minus 5 all over the whole thing, x. So then if you guys cross multiply that, you would have 2x is equal to 3 times x minus 5. So don't forget that's a couple. Couples stay together. So then you guys have to distribute the 3x minus 15. Then you would subtract 3x on both sides. You get negative x is negative 15. Divide both sides by negative 1. And you end up getting x is 15. So you end up having the height of the whole cone is 15 inches. Again, you don't need to label inches. If you just wrote 15, they would give you full credit. Okay, so then at the bottom it says determine and state to the nearest tenth of a cubic inch the volume of the water glass. So if we kind of go back up here, they just want the volume of this whole glass. So what we can do is we can find the volume of the whole cone, then the volume of the smaller cone, and subtract the two, and that's going to give us what's left over. So that's going to be our train of thought. So starting with the volume of the large cone. So that's what I'll label it. I'll say volume of large cone. Volume formula of a cone is 1/3 pi r squared h. So my radius of the large cone is half of 3 or 1.5. The height of it is going to end up being what my x was, and that was 15. So I know we didn't have to round or anything. It just kind of came out nice. So we have 1/3 pi times 1.5 squared times 15. And when you multiply that out, you get 35.342911735. So then you have to find the volume of smaller cone, or you could call it just small cone. Volume is 1/3 pi r squared h, or 1/3 pi. Now half of 2 is just 1, so it's 1 squared times the height of the small one is the x minus 5. So x minus 5 is 15 minus 5, or 10. So this one gives you 10.471975551. Okay, so I'm going to call this V1, this V2. The volume of the glass, okay, is going to equal V1 minus V2. And they want that rounded to the nearest tenth of a cubic inch. So you end up getting 24.9 cubic inches. Okay, this was, again, a 6-point question. This one had a little bit less going on. But again, the big point with this question is they wanted you guys to understand, like, yeah, we're looking at a 3-dimensional solid. But if you can kind of break it down looking at the 2-dimensional cross section going down, you really just have 2 overlapping similar triangles that you can set up proportions for with side lengths within the triangles. Okay, and that's it for this one, guys.